All right, gang, here with my father-in-law, Jim Albers, former NASA, obviously a lot of experiences there, Jim. So tell us about the SNAP 8 program, what that was.
Okay, the SNAP 8 program was the development of a space nuclear power system for space station. And this was in the early 60s. In fact, I started working on a program in 1963 when I first started NASA. But after looking at the effects of zero gravity on one of the components of the power system for many months, after we did all that research, which I talked about in the previous interview, we did a 10,000 hour endurance testing because it's supposed to operate, for like years in space with no interruptions. So we had the entire Space Nuclear Auxiliary Power System where we were running 24/7s, and I was one of the project engineers. This system had all the components of what the system that would have flown in space, with the exception of the nuclear reactor, where we simulated that with a computer. So we had a big control room where there were 2 engineers, 2 technicians, 2 mechanical technicians, and 2 electronic technicians. We had 6 people in each shift. After doing this test for maybe 6 or 8 months, on a rotating shift basis, 6 days off, 2 days on, sometimes days, sometimes 4 to 12, and then midnight to 8. After about running this for 6 months, I was a project engineer one night, and about 3 o'clock in the morning, we noticed some fluid leaking out of one of the cycles, one of the valves in this power system. And our purpose was to try to keep this thing going on a continual basis for 6 months. So when the mechanic saw this, he indicated that to me. I said, well, we need to go in and fix it. This system had a fluid called sodium potassium, which was the working fluid for the power system, but that would burn on more than 3% oxygen. So we had an argon enclosed environment to keep that oxygen below 3%. But the mechanics had to go in. I sent 2 mechanics in there to repair this valve. So they had to they had asbestos suits on with oxygen because there were no oxygen in there. They went in there, this is like 3 in the morning, to repair the valve. And before they went in, we brought the system down, but still rotating. In other words, the fluid would still be cycling in the different power loops, but we brought it down to lower pressure because that's the operating procedure on an emergency. So when they went in there, we noticed that one of the gloves of the mechanic actually started to burn. That means we had more than 3% oxygen. So I said, finish up as quick as you can do, and get out of there. So anyway, they were able to finish it and get out of there, and his glove was smoking, but when he got out, they closed the door as quick as possible, and then we were able to slowly bring the system back to operating conditions. But we had a major safety review that morning with the director of the center, and in this case was the Lewis Research Center. The deputy director of Lewis Research Center came in and personally talked to me about what happened, and then we went through a normal safety review. But that was very, very exciting for me to be a young project engineer in my 20s to want a $4 million space power system with everything but the nuclear reactor, and we kept it going for another 6 months or so. I think after the year was up, they decided that we had enough testing of this system, and so we essentially proved the operational capability of this space nuclear power system, which was really beneficial. The ironic thing, it was never used for space station because we ran out of money. It was kind of a backup system, and they went another direction, I think more towards solar and other things that were developed, later in the later years to support space station instead of going nuclear.
Fascinating stuff. All right, Jim.